So we're here at the CES 2014, and today was an Nvidia press conference. So who are you?
I'm Lazar Lewis, Product Marketing Manager for the Tegra K1 products. And we're very excited here to announce the Tegra K1 today. And what you're seeing here is Tegra K1 driving a 4K display.
So there's a 4K monitor right here.
4K display here. So this is like a tablet, a 4K tablet you can buy. And when you're at your home and you want to connect it and to a 4K TV at your house, Tegra K1 has the horsepower to be able to drive both the systems.
So it's right here. One 4K is not enough. You want to do two.
You want to do two, yeah.
Two 4K decode a video. What is the frame rate?
So you're getting 60 FPS here.
I don't know.
And in this case, it's a video playback, so you're getting video playback rates. But Tegra K1 can support 60 FPS on the internal panel, and this is through HDMI, so you're getting 30 FPS through HDMI.
But what if you have a HDMI 2.0 4K TV? Does it support dual 60 frames per second? Or
that one is in our next generation chip to support.
Denver?
No, we'll talk more about in the future on the future product line. But
Could
today,
we try to jump over there?
Sure.
So, please.
Yeah.
I mean, so as your product manager, what does that mean? Is it marketing or is it?
It is product marketing. It's marketing some I'm the owner who is working with engineering on setting up the POR and executing to the POR and helping share this goodness with our customers so we can bring very good products to market through our OEM partners.
So when the CEO said in the keynote, he said it's a 5-year journey.
Yes.
Has it been 5 years for you on this? No.
No, I started in Nvidia 2 years ago, but the whole team that's working on the 64-bit version of Tegra K1 has spent 5 years to get the best.
How?
64.
Like 5 years ago, it was already like in the plans to do 64-bit, all that ARM?
Yes.
Yeah.
We kind of saw the future coming. We kind of saw the capabilities of mobile where it was going, and we invested in doing a 64-bit processor. And the good thing is, all 32-bit applications will run faster, and the 64-bit applications will run, very nicely. So
and this is a real tablet. It's not fake.
It is real.
All the advanced graphics that's possible with the feature set, like subsurfacing acting, you can see the micro thing through
What we've done is we've taken the same product and just replaced with Tegra K1. And also we had put a 19 by 12 display because the mobile is going in that direction. So that's a 19 by 12 display. Tegra K1 in there. It's a 7-inch, very, very thin product. Same as the Tegra.
Same form factor exactly, not heavier. It's just the same PCB. You fit it in already.
Oh yes. So we're shipping Tegra 4 base Tegra Notes at $199, and we took the same ID and just replaced with Tegra K1.
So it fits in there, and it's that kind of like proves that it's not too far away.
Exactly. It is in a 7-inch product. You are looking at DX11 kind of quality, OpenGL 4.4 running. So all the demos that you saw here are running here. So the living room.
So I thought OpenGL 3 sounded like the very advanced latest stuff, but there's actually 4.4 now.
The latest is OpenGL 4.4.
That's the latest.
That's the latest, and currently the mobile products are supporting OpenGL ES 3.0. And what we're showing here is some of the capabilities on ES 3.0 is going to be limited, and with OpenGL 4.4 you're able to do more wonderful things. And in addition to it, PC games today need OpenGL 4.4 functionality. And by having support for OpenGL 4.4, PC games can easily port to Android.
So that means all the x86 PC games can relatively easily be ported over to this ARM part.
Yes.
With Kepler GPU. Really, I mean, what's the work needed to make a $100 million PC game work on this? Well, how much work?
So it depends on the project, but what I can give you is the Train 2 demo you saw there on the screen today took around 2 weeks to port from PC to mobile. And some of the demos like the FaceWorks and the other things you saw today took around 1 to 2 weeks. We had done it on Titan, on DX11. We took that and just ported over to OpenGL 4.4. Without it, you have to do a lot of translation back to ES 3.0, and you won't have the same quality like we showed when you do it on ES 3.0. So it's important to have OpenGL 4.4 to enjoy the goodness of PC games on Android.
That's like kind of like it's been in the works 5 years to get the GPU of the PC to work on mobile.
Yeah, so we had this vision to bring the same architecture both in PC and mobile. And so we started designing our chips mobile first. And so we can scale it across the PC, the supercomputers, and the cars. And by designing mobile first, we're able to benefit that now. And all the tools and drivers we have written for the PC, they are leveraged here. And so PC game developers have tools that they use on the PC, they can use on mobile now. So they can see what different effects they want to do, how to optimize those effects quickly and bring it to market.
And Android is already smooth? All the graphics acceleration of all the Android stuff?
Yes.
How long time did that take?
So we had this chip back 3-4 months back, and so we started optimizing Android for Tegra K1, and we are very close to production here. We have production samples now, and Android is very optimized and
so
running
that's
well.
where the ARM is quad-core A15?
Yes.
And that's been 3-4 months in your labs?
Yes, it's been in our labs for 3-4 months, and the Android A15 we're releasing in Tegra K1 is better than the A15s that was in Tegra 4.
How is it better?
So we are using a newer release of ARM, the R3 version. In addition, we have done some architectural changes from our learnings in Tegra 4, and we can share with you curves to show that the Logan K1 or Tegra K1 version of A15 is actually significantly better than the Tegra 4 version of A15, also significantly better than the Exynos A15 versions. And
it's also better than the latest octa-core from Samsung?
We measured the recent Samsung device, and it's significantly better in terms of power and performance. So with that, and in addition having the Kepler and its power advantages, you are able to provide long battery lives for use cases like gaming or even just rendering, on the UI. Just very good battery life because of those two things.
So the GPU is not even like next gen compared to before. It's like if you can get close to that one, it's a huge leap. But how would you compare this to, let's say, the latest shipping Mali GPU that's in the Samsung octa-core, for example? How's it different?
So this one here is the first GPU that supports OpenGL 4.4. So significantly different than what's there today and what people are going to bring in the next couple of months. And being able to deliver beautiful visual effects and gaming performance.
And 192 cores is including the ARM cores?
So that is just the GPU. 192 the CUDA compute cores, and then on the ARM side we have 4+1. We have 5 cores on the ARM side.
So it's 196 cores, you would say, or what?
It's 197 cores, and then we have hardware decode blocks for video decode and encode. We could do 4K video decode and encode in this chip because of the hardware decode blocks. And in addition, we have ISP, dual ISP, to deliver very good imaging experience. So Tegra K1 packs in the best GPU, the best A15 CPUs, beautiful audio, decode engines, and image processing engines to bring in the best experience.
And then there's a K1 Denver. How much more time do we need to wait for that one?
So as Jensen said earlier, he's looking forward to sharing more information in the next couple of months. We just got the chip a few days ago, and we were happy to show the demo today that it's fully up and running, and you're able to do the UI and run video playback. And
so there's one of these that has it now. It's somewhere over there.
So the one that you saw in the demo, I was running a reference platform with a 19:12 display and showing Logan 64 Android running on it. So we have we have it in the lab working on it, and so we'll make announcements in the near future about the performance benefits and the use case advantages of the Tegra K1 with a 64-bit CPU.
And so can we hope for it to arrive in products in this year?
Yes.
Denver for sure this year.
Yes.
And this for sure very soon.
This is very soon. I think timing is Q1, Q2 this year, and Denver will be the second half. So we're looking to productize Denver in the second half of this year.
Yep.
Awesome.
Because I think
that's very cool. When there was a Tegra 4, there was a whole bunch of modem stuff announced. Is that just also here? Modem stuff. And,
so the modem we announced, the i500 modem, that works here. So we're working on connected versions of these tablets where we have the i500 module inside the product. So you have a connected version of the same tablet.
Right. And what is that form factor? Is it like a set-top box, or what is that? Could there be set-top box laptops?
That one
what
there?
are you going to see?
This 4K here?
It's just
So 4K, we expect that to be in tablets. You know, there are display manufacturers that are looking at 4K, OEMs that are looking at 4K tablets, also clamshells. We're going to be seeing 4K in the clamshells.
So clamshells means laptops. Convertible tablet laptops.
Yeah, convertible. You know, yeah, it's like, you know, you got clamshells today that are running Chrome.
And what's going to happen with Android 5? Can you say anything?
No, I cannot say anything about Android 5.
Because I guess it could be a bunch of features that could really take advantage of this.
Yes.
Like desktop kind of stuff and entertainment kind of stuff. Like really take advantage of it. We need to take advantage of these new amazing accessories.
Yeah, you know, we are good partners with Google. We're working together with them and, you know, collaborating with them so that they can bring the goodness of the next generation Android through some of these devices.
Or a small startup trying to build any new gadget. The Android operating system is the most accessible and the most capable operating system you can get your hands on. It's open source. No wonder the computing revolution in China took off on the backs of the Android operating system and is now the fastest growing mobile computing market in the world. Android started out in the phone industry, completely disrupted the phone market. Then it worked its way into tablets. But that's not where it's going to end. Because it's an operating system that's free to all. Because it's an operating system that allows every company, every country, every industry to freely innovate. And because it is a virtually complete operating system, by virtue of the fact that so many of us made contributions to it, there are more engineers working on Android. There are more engineers working around the world in the Android ecosystem than any ecosystem today. And so it stands to reason that the positive feedback system is going to fuel its disruption. At this point, it's kind of hard to imagine stopping it. But it's wonderful for the world. When we think about building Tegra, our mobile processor, we think about what we can do to take the Android operating system, in combination, take it into new markets. Markets where our expertise can especially serve. Markets where visual computing matters. We started out by building the Tegra 2, the world's first dual-core processor. At the time, people asked us, why would you need a dual-core processor? Then we took that to Tegra 3, the world's first quad-core processor. People asked us why we needed a quad-core processor. And it's all very clear now that in a mobile environment, in a mobile context, there are more and more activities that are happening simultaneously. So the question is, where do we go from here? Now there's some new industries that I think Android will continue to advance into and make a contribution to. One of them, of course, is television. That one's a foregone conclusion. It's not if, it's simply when. 4K televisions are coming, smart televisions are coming. It stands to reason that Android is going to be a very important factor in that. Consoles. We happen to believe that the Android operating system is going to be the most important platform for game consoles in the future. And the reason for that is because you have all of your digital asset in Android. Why would you want to be home, connected to television, and then have access to all of your photographs or all of your music, of all of your movies, and all of your video games? It's simply a matter of time. It's simply a matter of time before Android also disrupts the video game console industry. It is the reason why we built Shield, so that we can engage it and start to make a contribution to it. We also believe that Android would make a difference in the car industry. The car industry is one of the most exciting industries in the world for many of us because we love cars. But there's a second reason. We happen to believe that the car will be your most important mobile computer. It is likely to be our most personal robot someday. It is already our most expensive consumer electronics owning, and it stands to reason that it's also going to be the most advanced. Now, it happens to have some of the most pioneering minds and some of the brightest engineers working in that industry, because they also love cars. And so I think this is an area that's going to make huge contributions, and I'll come back to that in just a moment. And so the question then, after Tegra 2, the world's first dual core, after Tegra 3, the world's first quad core, and then we double the performance of that with Tegra 4, what's next for us? What's next for us? I mean, what could we possibly do? I guess we could do 8 cores,
16.
but that seems pretty pedestrian. That seems pretty obvious. We could do 12 cores, that's more than 8. However, I think that maybe we could do better than that. What we decided to do was we decided to make Tegra K1 the world's first 192 core processor. A 192 CUDA cores, all programmable by programs, all fully programmable, all massively parallel. And this is the first GPU. The reason why we decided to call it Tegra K1 is because this is the first GPU that took a vast jump from the previous generation. It's almost inappropriate to call it Tegra 5 because it's simply not linear. We decided to call it Tegra K1. We decided to call it Tegra K1 because it's based on the Kepler architecture. As many of you know, Kepler is the most successful GPU architecture that we have ever created, and it's the most important GPU architecture the industry had ever known. This architecture, because it is so energy efficient, has made it possible, and so programmable, has made it possible for us to extend the GPU from not just desktop computers to workstations, but all the way into the cloud with Grid, and into supercomputers with Tesla. One singular architecture, all compatible, is now able to span computing from a few watts all the way to megawatts, from 192 cores all the way to 36 million cores running our nation's fastest supercomputer. All based on the exact same architecture called Kepler. So we're really, really excited today that with Tegra, we've bridged the gap. We've brought mobile computing to the same level as desktop computing. We've brought mobile computing to the same level as supercomputing. We've brought the heart of GeForce and the soul of Tesla to the Tegra family. We've brought the heart of GeForce and the soul of Tesla to mobile computing. And we're really excited about that. Now, what's the benefit? What's the benefit of that? Well, the first benefit is solving, in fact, a very significant problem for game developers. If you take a look at game development today, just as you saw with Batman, the production value is incredible. It's completely cinematic. It's cinematic and also interactive at the same time. The computer graphics is cinematic. The experience is cinematic. The story has to be sufficiently broad and large and large in scope that you can actually enjoy the video game for 8 hours at a time, 10 hours at a time, 20 hours at a time. So there's enormous depth to the video games. And it stands to reason, with so much artistic contribution and so much technical contribution, that the production value, the production cost would be so high. In fact, most AAA titles today cost more than $100 million. Now, there's only one thing that you can do to solve that problem. You could either reduce the production value, or you have to have a larger footprint. You have to find a way, as a game developer, to reach more users. Well, in order to reach more users, unfortunately, the architectures are radically different. When you take a look at each one of the game platforms, the architectures historically were very different. They're becoming more and more similar. However, the architecture of mobile devices, which is the largest computing platform in the world today, and the architecture of next generation game consoles are radically different. One of them is based on OpenGL ES 3.0, and the other one is based on OpenGL 4.3. The capabilities are radically different. The capabilities, the features. And so, for a game developer, the diversity of the platforms creates another degree of complexity that is simply intolerable. The developer's dilemma. They want to build great games, they want to take the financial risk, but they need to have large enough footprint that can accept and help people enjoy the creation that they make. And so today, we're incredibly excited to announce that Epic Games is going to bring their next generation engine, the Unreal Engine 4, to the Tegra K1. And Tim is a man of few words, for all of you guys who know Tim. And he has the highest expectations. We've been working with Tim now for 20 years. He has the highest expectations of anybody in the game industry. And he says this so cleanly. He says we can take absolutely anything that runs on PC or high-end console and run it on Tegra now. I didn't think that we'd be at this level on mobile for another 3 to 4 years. Now let's take a look at what he meant by that. So if you look at this, this is Unreal Engine 3. This is the last generation game console. In the year 2002, we launched NV30, which was GeForce effects, with the invention of DX9. DX9 brought to the world programmable shading. And the effect that we saw in video games were per pixel lighting. So video games became bumpy and shiny. Okay, whereas before it looked chalky and flat, now it looks bumpy and shiny. It came to life. And modern video games are still based on DX9. It wasn't for several years later that Xbox 360 and PlayStation 3 brought DX9 to game consoles. And then many years after that, it came to mobile devices. For the very first time, with Unreal Engine 3, with Infinity Blade from Epic, running on an iPad. iPad was the first capable machine to be able to run an engine that was introduced in the year 2002. A span of 8 years' time. A span of 8 years' time that it took for the Unreal 3 engine that runs on Xbox 360 and the PlayStation 3 to finally be able to run on a mobile device. Well, that entire 8 years is what we consider last generation. It was the DX9 era. The DX9 era. If you take a look at most video games today, with the exception of some of the more modern video games that we're showing you, when you take a look at a mobile device or you look at a video game today, it's mostly DX9. That's the look of DX9. Well, here is the beginning of next generation. Next generation started with DX11.1. I'll show you what DX11.1 can do in just a second. We introduced it with Kepler. 1 year later, because of this incredible imperative to unify the platforms for the video game industry, the new game consoles are effectively PCs. It's architecturally identical to a PC. It's because of this incredible imperative to keep the platforms the same. 1 year later, the game console industry brought the same architecture to game consoles. As a result, now the game developers have a reasonable footprint to target with next generation DX11 games running Unreal Engine 4. But here's the really exciting thing for Tim. And what he said earlier is this. This time around, because of what we've done with Tegra K1, we have now reduced the amount of time that it's taken for next generation platforms to be able to reach not just PCs, not just consoles, but also mobile devices of all kinds. The benefits to game developers is really immense. Literally one singular architecture, one singular platform, and more importantly, one engine. Now the Unreal Engine, many of you guys have known, have been tracking the video game industry, is the most successful game engine of all time. Unreal Engine is effectively the operating system of games. The game AI, the game physics, the game rendering engine, it basically embodies the runtime of modern video games. Unreal Engine 3 had hundreds of games that were credited to it. And here comes Unreal Engine 4, the next generation. So that's what Tim is really excited about. Now when you take a look at Unreal Engine 3 and you compare that to Unreal Engine 4, it's really incomparable. Because Unreal Engine 4 is all about being photoreal. This relentless pursuit for photorealism. Several factors, several characteristics make the next generation game content look so distinguished relative to the previous generation. The first thing that you'll see is that all of the rendering is physically based, meaning that we're capturing the microstructures of the materials and how it responds to light physics. And so as a result, you could almost feel the material physics, the material properties of everything in the scene. The second thing is the advanced lighting systems. It's no longer just the unidirectional light. Light is coming from all over. It's as close to global illumination.
Yeah, so this is a wonderful demo that Epic put together to show off some of the features of their engine. As you mentioned, the art quality is second to none. The textures are amazing, and also lots of little effects. As we go around, I'll point some of them out.
Look at the water dripping off the wall.
Yeah, up here.
The lens flare. You look at the sun, high dynamic range. Look how bright the brights are and how dark the darks are. Okay, imagine a camera doing this. Really hard time with a camera doing this. Now it's computer graphics doing this. Generation graphics capabilities called DX9. Tegra K1 is based on DX11. But if you look at the horsepower, just the raw horsepower alone, the GPU has more horsepower than both Xbox 360 and PlayStation 3, and the CPU is far and away more powerful than both the Xbox 360 and the PlayStation 3. And all of that is made possible because of mobile technology now available in just a few watts. And so what you're going to have is essentially the visual richness of next generation capability, but the horsepower of a game console right in your palms. Really, really amazing. So I'm super excited to introduce Tegra K1 to you. Now, if you were to compare Tegra K1 to another platform, this is the most advanced processor on the market today, the highest end tablet from Apple, Apple's with Apple A7. And if you compared TK1, Tegra K1, to Apple's A7, is almost 3 times the performance on just a benchmark that runs using yesterday's graphics technology, OpenGL ES 3.0. Okay, this is using old, last generation computer graphics technology. We're already miles ahead. But when you consider next generation graphics capability, we're just so far ahead at this point, and that's the reason why Tim Sweeney is as excited as he is. Tegra K1. Well, there's a lot of things that I can tell you about Tegra K1. There's a lot of features I'd love to show you. I urge you to take a look at the demos that we have set up for you. The 4K demos, the UI, is really, really beautiful. When you take a look at all of our camera applications and camera capability, super exciting. The performance is wonderful. So there's a lot of things I can go over with you, but I really would like to focus on one surprise. Tegra K1 is the world's first 192 core processor. But I have one surprise for you. Tegra K1 comes in two versions. The first version, one version is the quad-core A15, but another version is based on our Denver CPU. We've been talking to you about Denver for some time. This is an endeavor that we've taken some time to do. It's a full custom CPU. It is based on ARM's V8 64-bit. It's designed to be very high performance single-threaded and very high performance multi-threaded processor. And I'm delighted to announce today that Tegra K1 will also come with dual-core Denver. Now I know what you're thinking. I know what you're thinking. This is probably a PowerPoint launch. Right? Right, okay. Well, I'm happy to say that Tegra K1 with dual-core Denver has been back for a few days. It's been back for a few days. And I know how excited everybody is about Denver. And so I thought, you know, what the heck? Let's give it a try. And ladies and gentlemen, this baby's only been back a few days, okay? And if she falls on her face, trips up while she's introducing herself to you, let's all cut her some slack. She's only been out a few days, okay? So ladies and gentlemen, Tegra K1 with Denver. Now, what you're looking at is the Android operating system running on Tegra K1. And Lazar, why don't you take it out for a spin? Yeah. Wow, look at that. It's only been... I know. That's this. Like the applause comes from only geeks. Everybody else in the room's going, I've seen a desktop. You know? Well, look. When you work on a chip for 5 years, and it comes back and it's not a brick, you're just so happy. I am so happy. So Denver is a full custom CPU. It's going to be incredibly fast, and this is the world's first demonstration of 64-bit V8 ARM on Android. And so let's prove it to them. Wow, that is really sexy, guys. There you have it, ladies and gentlemen. Tegra K1 with dual-core Denver 64-bit ARM CPU. All right. Well, let's not push this baby too far. Okay, let's not push this baby too far because we have a few more demonstrations to give you, and I don't have very much more time. So thank you very much, Lazar. Good job. So there you have it, Tegra K1, the world's first 192-core super chip. It's one chip with two versions, quad-core A15, dual Denver CPUs. A15 is obviously 32 bits, Denver is 64 bits. A15 is 3-way superscalar, Denver is 7-way superscalar. It runs up to 2.5 gigahertz, and it's got a pretty healthy cache, 128 kilobytes and 64 kilobytes of I and D L1 cache. Okay, ladies and gentlemen, Tegra K1. And it was really interesting. We were describing this to one of the reviewers of Car and Driver, and he literally just said himself that this is next generation Tegra will perform at this level with 384 gigaflops with 4 processors per car. A 2-car garage would have as much computing power as a $120 million Blue Mountain supercomputer. So he quickly equated it to a supercomputer. And in fact, just as Tegra K1 has the heart of GeForce it does have the soul of Tesla. It is the identical same architecture. This architecture powers the world's 10 of the top 10 greenest supercomputers. Every single energy efficient supercomputer in the world today, in the top 10 list, are powered by the Kepler architecture. That same architecture is now in Tegra K1. The question is, what do we want to do with it? I want to show you two things. I want to show you two reasons why we need a supercomputer in future cars. The first reason, of course, is advanced driver assistance. This is an area that has incredible focus today. It's incredibly exciting because this is the path that leads to the semi-autonomous cars. This is also exciting because it's going to bring magic to the car industry. Your car is going to do things that most people won't be able to understand. And they won't be able to understand it because we have a supercomputer in the car doing amazing things. Using image processing, computer vision, artificial intelligence, and all of the technologies that we've invested over the years, it is now possible, with a rich number of sensors around the car, to do magical things of algorithm enhancement. What starts out as detecting a feature, which is a car in front of you, collision avoidance, slowing you down, recognizing lanes, keeping you inside the lane. These features will quickly evolve to the point where your car finds its way eventually to becoming an autopilot. We're super excited about this new capability. It brings to bear our last decade of work in the area of computer vision and GPU computing, and all the work that we've been doing in this area, we can now bring to bear for the very first time in mobile devices. So Tegra K1 for ADAS.
And so these two parts would actually go into a car. This represents a K1 tablet that you might have at home or at a showroom that would let you configure. So you can see it's actually running Android, which is totally different than something that would be behind the steering wheel for gauges themselves. So let's start by looking at this part that would be in the car, because this is ultimately what's the most thrilling part of this. So as we zoom in on it, you can start to see the detail of the materials. And as you were talking about, Jensen, we've been using physically accurate materials to render designs for the exterior of vehicles for a long time. So what we're doing here is we're taking those exact same materials called MDL and we're putting them inside the car. So you can see up here brushed nickel. This is like a powder coat here, shiny titanium. It's very highly detailed, and I welcome you to come to the demo room and get a very much closer look.
Well, let's configure something.
Okay.
Let's make something for ourselves.
Okay. So right before I'm going to drop down and configure it, I just want to point out that we've got film quality details to this. We realize that something to look realistic has to be nearly perfect. So we can see this is all 3D, depth of field, refraction on the glass, illumination from the environment. We can change the environment and create warm glowing lights that you might see inside of the car. So dropping down to this configuration that you might have inside of your room, living room, or maybe
more surprise. I do have one more surprise. Maybe this is more of a confession. This is not quite a surprise, this is more of a confession. So Tegra K1 is probably the most ambitious project that we have ever worked on. It is the culmination of many years of work in the GPU industry, taking the same architecture that is the heart of GeForce, the soul of Tesla, the same architecture that runs and powers the nation, our nation and the world's supercomputers, and to bring it into a mobile form factor so that we can revolutionize mobile computing. The two very important areas that we wanted to revolutionize was bringing next generation games to mobile form factors. It could be a mobile device like a phone, it could be a tablet, it could be a game console that utilizes mobile technology. The second area was automotive. We believe that such a supercomputing technology inside your car could help revolutionize the car and can make possible next generation cars to come more quickly. And so I told the guys, look, you know, Tegra K1 is impossibly advanced. It's impossibly advanced. It's like out of this world. It's practically built by aliens. And the engineers have worked so hard on this for so many years. I want you guys to go out and launch this product and put a marketing campaign behind it that is of equal, that rivals the technical contributions. I want you guys to go do something that when we sit back, will have global reach. And people will think that, my God, everybody knows about it. And by the way, you have no marketing budget. And so, ladies and gentlemen, it is true. The Nvidia marketing team is behind this phenomenon. What you're looking at here is 310 feet in diameter. It is what people call a crop circle. This is a field of barley. I told them no animals can be harmed in the spectacle. No money should be wasted. And the environment should not be damaged. A global launch, something of the magnitude of Tegra K1, and of course no budget and no one can be harmed. It's an impossible task. And what they came up with was this crop circle. Now this is a field of barley. It turns out the barley is between cash crops and it'll just be plowed over. So there's no food was harmed. And because barley is pretty inexpensive, no money was wasted. Now what was interesting is this. This is in a small town south of Salinas in California. And when I learned about it, I saw it on CNN. I saw it on headline news CNN. People thought aliens had done this. And the coverage has been fantastic. Canada to the south, Brazil and Mexico, all the way to the west, Thailand and China, and to the east, UK, of course, where all the crop circles start. Aliens go to. And the coverage has been fantastic. The coverage has been fantastic. These are a couple of our favorites. Somebody wanted to throw a New Year's party. If you could read that, it says, crop circle in Chular, California. Chular, California, by the way, has 1,100 citizens. They have since been visited by fleets of helicopters from news stations. Hundreds of people have pulled off the side of the road to take a look at this astronomical phenomenon.